Hey, Mr. Harridan here. We're going to go over measurement and observations here. As a reminder, there are two basic types of data collection in the lab. There's the numerical, which is quantitative, which I like to call as precise. And then there is the non-numeric, which is qualitative. Which is non precise. Okay, and now we're going to go over two different terms, accuracy and precision here. And I'm going to spend most of this talk talking about accuracy here for the first one. Accuracy refers to the degree of closeness of the measurements to the true value. The accepted value is also referred to as the true, actual, or theoretical value, which is what you find in a book. You look it up in a reference chart or something like that. Okay, and then there's an experimental value that you get from the experiment. Usually, what you have here is you have an average of data points, and you're going to compare to the true value. Okay, you have to have the average of the data. Okay, and you also have to have the true value that you have to look up in a reference book. Give you a second to write that down since I'm not on the screen. What we do to usually figure out accuracy is you use a percent error, and you use this formula, which is listed on your formula chart. Okay, if the experimental value you got in the lab can be either positive or negative. Positive number means that your value was lower than accepted, and a negative number means your value is higher than the accepted. Okay, so moving on here, let's look at example 1.4. A student determines the mass of a beaker using a balance and records its mass to be 47.21. That is the experimental value. The accepted mass of the beaker is 47.93. This is the accepted. What is the percent error? Usually you should write down the formula. I like you writing down formulas first before you plug in numbers. Percent error equals accepted minus experimental over accepted times 100. And then we substitute in the numbers here. The accepted is 47.93 minus 47.21. Oh my goodness, you're not writing down the right numbers, Mr. Harridan. Mr. Harridan, you need to write down the right numbers. Divided by 47.93 times 100. And you get an answer. And the answer to this one is 1.5%. Okay, and we'll go over how to round that eventually. Okay, here's where students struggle here with example 1.5. Example 1.5. Billy Fumblefingers lab group had a 22.5% error in their lab. Usually you want to have an error that's 5% or below. That's how I know if it's accurate. If it's 5% or below, it's accurate. If it's above 5, it's not accurate. They found the mass of the object to be 122.4 grams. So this is the experimental number. This is the percent error. What is the accepted mass? So that's what we're looking for, as written on the board by their teacher. So first thing we're going to do is write down the formula again. Percent error equals accepted minus experimental over accepted times 100. Okay. Now we're going to plug in our numbers here. We know that 22.5 is our percent error. We are looking for the accepted mass, so I will use an A for that. Minus 122.4 over A times 100. Okay. So the first step we're going to do in this problem is usually when you have a variable on the bottom of your fraction here, that's bad. So we're going to end up multiplying both sides by A, which you're just going to see me shift the A over here like that. Because I'm multiplying by A on this side, this is going to cancel. I'm going to multiply by A on this side, put an A over here. So that's going to give me 22.5A equals A minus 122.4 times 100. Okay, the next step I am going to do here is distribute the 100. So this stays 22.5A equals 100A minus 12240. The next step you're going to see me do here is combine my like terms, which I'm going to subtract 100A from both sides, because this cancels, leaving me with, what's that leave me with? Negative 77.5A equals negative 12240. Then we divide by negative 75.55. Write the right numbers, Mr. Herodom, because these will cancel. Sweesh, sweesh. You'll learn that later. And then we get an A of 157.9 grams. Easily done. So the steps for solving this problem here is to get rid of the fraction, distribute, combine like terms, and then divide. What do we say about that? Thank you. Thank you. Thank you. Thank you. Yes. I am the legend. Thank you very much. Okay. I am going to leave. Okay, that's enough. That's enough. Okay. These next two for you to do. I'm expecting these that you are to do these on your own. And I was going to give you the answers to them, but I guess I'm not going to give you the answers to them. I will give you the answer to this one, though. I know the answer to this one is 22.4 liters per mole. And you're going to show work. It's just like example 1.5 I did, and example 1.6 is just like example 1.4. You guys are champions. The legend is